In this video, we will be defining the rational zero theorem. If we let f of x represent a polynomial function with integer coefficients, so here is f of x. To define this f of x, you just need to know a sub n minus 1, a sub 1, a sub 0. Those are your coefficients of the variables, and a sub 0 is your constant of the function. X to the n minus 1, dot, 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 x to the first power, and then no x. This is just showing you your exponents are descending in order. In other words, it's in standard form. So that helps you see what this symbolic representation of the function f of x means. So if we have this function, if p over q is a rational number in simplest form and is a zero of f of x, remember zeros are your roots, they are your x-intercepts, then we know that p is a factor of the constant. So here's my constant. So factors of the constant are my p-value. And q is a factor of my leading coefficient. And so a sub n is my leading coefficient. What does this mean? This means if I have a polynomial function written in standard form, the exponents in descending order, then if I look at my constant and I look at my leading coefficient and I set up, with all of the factors, fractions, then in that list somewhere is my possible rational zeros. Now, the rational zero theorem gives you a list of possible rational zeros. It doesn't tell you every single one of those is a zero. It tells you, somewhere in this list will be a zero of the function. So we're trying to figure out what the possible ones are, and then we're going to kind of go from there as we dive further into this lesson to see which ones actually are. So the rational zero theorem means put your function, your polynomial, in standard form. P are factors of the constant, and Q are factors of the leading coefficient. And we set up fractions with those factors, simplify them, and those represent the possible rational zeros. To see this applied, just move on to the next video.